This is lesson 27 for 7th grade, module 6, on volume of right prisms. Now, as you see here, we have this opening exercise where it wants you to take your paper and create this triangle, cut it along the dotted lines, and then take these pieces and form it into a right rectangle with all right angles, obviously. So what that would look like is this triangle here would flip over and land on top of here, which would allow this to extend out. And then this one here would do the same thing. It'd flip over and the triangle would go this way. Now, what the point of this is to show you, and since we're watching this on the video and we're not going to do it in class either, is just because of the time. But what you're supposed to notice here is if you were to find the volume of this triangle, it would be the same thing as finding the volume of this whole rectangle. It would give you the same answer, because if you just cut these pieces off and stick them up here, cut this piece off and stick it up here, it's still the same volume. All you did was move some of the pieces around. So kind of keep that in mind as we go through some of these exercises today, that some of these can be taken off, kind of like you see in this picture here. I could take this triangle off, split it into two pieces, and place them on the ends here to create that rectangle. And in doing so, our volume is going to be the same, or it should be the same. So let's start with this one. We're going to skip that first one, so you can just put skip on your papers. So we're going to start with exercise 1. Show that the following figures have the same volume. So we're going to prove it right here. Let's do the volume of the triangle first. So I'm just going to put volume triangle. All right, and as you remember, volume of a triangle is going to be half your length times width times height. Half because it's a triangle. Triangles are half of a rectangle. So we're going to say half of 8 times 9 times 8. And again, it doesn't really matter what order those go in, because multiplication can go in any order. We're going to go ahead and multiply these together. I'm going to group them real quick just to make it a little easier. This is 72. 72 times 8. Bring down my half. 72 times 8 gives me 576. So I'm going to say half times 576. Remember, fractions just mean to divide. So 2 will go into 256, and it'll come out to 288. And let's put our units, centimeters cubed. Cubed because we're finding volume. All right, now let's come over here. What if we just had this rectangle? So let's say volume of a rectangle. And as we all know, volume of a rectangle is just length times width times height. So for this one, we're going to do 8 times 8 times 4.5. All right. Now, if we multiply that all together, 8 times 8 gives me 64. 64 times 4.5 gives me 288 centimeters cubed. So as you can see, we get the same volume. If you fill this up with water or you fill this up with water, it's going to require the same amount of water. All that's different is the shape. And that's what volume is finding, is how much can I fill on the inside. So let's answer this question here. We have, how can it be shown that the prism will have equal volumes without completing the entire calculation? So what they're asking for is, how can we tell that the triangular prism is going to give me the same volume as the rectangular prism? And so what we can say is you can cut, and this is kind of goes back to that opening exercise that I explained to you at the beginning. You can cut the triangular prism into two sections to form a rectangular prism, which will give you the same volume. So basically what we've been kind of talking about for a few minutes here is that just by rearranging those pieces to make it into a rectangle, will still give you the same volume. All right, so let's calculate the volume of this prism here. So the first thing I see is I want to go ahead and find the base. The base being my top and my bottom, and then we'll find the volume of the whole from top to bottom, including that 3 for the height. So for right now, we're going to do volume of the base. Oh, sorry, not volume. I got so used to saying volume that my brain went there. Area. I want to find the area because I'm going to find the top and the bottom, then the volume. Sorry, I apologize. Area. How big is this right here? All right, as well as the bottom, and then we're going to fill it up. So let's find the area of the base. Now, I'm going to take this apart. Let me go ahead and erase my coloring there for a second. I'm going to kind of outline what I'm doing here, just so you can see the different pieces. I see right away that I actually have 2 triangles. If I cut this right down the center here, I have a triangle that goes this way. So I'm going to find the area of that triangle, and then I'm going to add it to the area. We'll get a different color. I'm going to add it to the area of this triangle. Okay, and as we remember, area equals half base times height. So I'm going to do half of 20 times 18, and then add that to the other one, which is half 4 times 18. Now let's go ahead and do some math here. 20 times 18 is going to give me 360. So half of 360 plus half of 4 times 18 gives me 72. And as remember, fractions just mean to divide. So 2 goes into 360 180 times. I'm going to add that to this. 2 goes into 72 36 times. So the area of my top and bottom is going to be 216 inches squared. Now, if this is 216 inches squared, now I just need to incorporate this height into that as well. And by doing that, I can find the volume. So since I already found some of the parts of the volume, I found the length and the width basically. Now I just need to incorporate the height. So for volume, we're going to say volume of a prism. That's going to be basically your area times 3. And that's because we have to incorporate that height. So I'm going to say 216 times 3 gives me 648 inches cubed. And that is my final answer. But I do also want to box this answer because that was needed in order to find the final answer. So when I grade these, I will be looking for all the answers that are needed for the problem, not just the final answer, as well as your work. All right, let's go on to the next page. This one says, a container is shaped like a right pentagonal prism with an open top. That means there is no top. It's like an empty box with no lid. When a cubic foot of water is dumped into the container, the depth of the water is 8 inches. Find the area of the pentagonal base. All right, so first let's get used to drawing a pentagonal prism. Pentagons remind a lot of us of houses. But when you're drawing it in 3D, sometimes you don't want it to look exactly like straight down like a house. You kind of want to diagonal these out a little bit. Okay, and then you're going to go straight down here, straight down here, straight down here, and straight down here. You're going to go ahead and connect these. Now that is a pentagonal prism with the lid. Okay, to make it look like it doesn't have a lid, let's go ahead and put in the inside. Like so. Now, of course, mine's not perfect being on a tablet, but you kind of get the idea. All right, so the first thing I notice here is they give us some information. We have 8 inches. And I want to move that to feet. And the reason I want that in feet is because I fill the water up in cubic foot. So I can't have inches and foot. So I need to transfer that. So I'm going to do 8 divided by 12 because there's 12 inches in a foot, and that gives me 2/3 of a foot. So my depth will be 2/3 of a foot. So now when I go to find the volume, we're going to take the big B times the H. All right? Big B is the area of the base. So whenever you see this big capitalized B, because normally it would just be base times height, when you see the capitalized B, that means the area of the base, the length and the width already put together for you. So they tell me here that it is 1 cubic foot of water being dumped into the container. So we're going to say with 1 cubic foot will equal the area of the base times the height. So that'll be 1 foot cubed equals big B, which I don't know because I don't have enough information for that. But I do know the height. The height, let me see if I can switch up colors here for a second. The height of this guy is 2/3. Okay, and that was the 2/3 that we found right here. All right, so we're going to times this by 2/3. Okay, to get the big B by itself, I'm actually going to divide out that 2/3. And what you do to one side, you do to the other. My 2/3 cancel, and what's left over here is instead of dividing, I'm actually going to multiply by its reciprocal. So I'm going to flip this 2/3 around to multiply by its reciprocal. So I have 3/2 times 1 equals big B. Therefore, my big B equals 3/2. So that's my area of the base. Now, I could say 3/2, or I could say 1 1/2 feet squared. And this will give me my area of the base. And we're done. All right, let's look at example 3. Example 3 says, 2 containers are shaped like right triangular prisms, each with the same height. The base area of the larger container is 200% more than the base area of the smaller container. How many times must the container be filled with water and poured into the larger container in order to fill the larger container? So basically you have a small box and a bigger box. Okay, so I'm just going to draw us a little visual here. We have a smaller box. Now this smaller box by itself does represent 100%, kind of like when we were doing scale factor. The original is always going to be 100%. The bigger one, as they told us here, this is a bigger container. Now I know it says triangular, but we're just rolling with boxes right now. The triangular is 200% bigger, but actually this bigger one included that 100. So kind of picture that it's in there. So there's a 100% and then the 200%. So it's actually 300% bigger. And that's because it was the 100. It's the original plus more. How much more? 200 more. So it's 100 plus 200, which gives me 300% bigger. So it's not just times 2, it's going to be times 3. So first, let's talk about the smaller one. All right, we're going to find the volume of the smaller one. And remember, volume equals your big B times your height. And I remember big B stands for your area of your base. So let's just write down our information here. We have our base. I'm just going to actually plug in some numbers because they didn't really give us any numbers to go off of. So in order to see how many more times you have to put water in there, you could actually come up with any of your own numbers, as long as it just, shows that you're increasing the other one by 300%. So I'm just going to pick up some easy numbers here. I'm going to say that my base is 10. I'm going to say that my height is 5, and these are all inches. And then I'm going to say the prism height is 2. All right. So first I'm going to find my big B. Find the big B, I find the area. Area is going to equal 1/2 my base times my height, which is 10 times 5. So that's 1/2 of 50, which gives me 25. That gives me my big B. So now when I come up here, I go 25 times the prism height, which is 2, and I get 50 inches cubed. All right, that's all for the smaller one. Now let's look at how big is the larger one. And again, my larger, I'm just going to say my volume is 300% bigger. So instead of doing all this work again, I'm just going to take 50, my answer from the original, times it by 3 because of 300, and I get 150 inches cubed. All right, so my final answers here, we have 25 for the big B. We have 150 here. These are answers I do need. So we can now say that seeing the difference here between the 25 and the 150, we can say that the smaller, oh, excuse me, not the 25, the 50. You need all 3 of those. What's the difference between the 50 and the 150? There we go. Sorry, that didn't quite make sense when I said it out loud. The smaller would have to be filled 3 times, and I wonder why it's 3 times, to fill the larger. Now, why does it have to be 3 times filled? Because it's 300% bigger. So you think about it. This is filled with water. When I pour it into this bucket, I only fill up this portion. So then I need to fill it up again. And let's say it fills up that portion. And then I fill it up again. Now it fills up that portion. Why? Because it's 300. There's 3 of these basically in this one container. I can fit 3 small ones in the larger one because the 100% plus the 200 gives me that 300%. All right, you guys are going to do exercise 2. That'll be one that I grade. You're basically answering the question, are any of the girls correct in their ideas of how big this aquarium is going to be? And why? Why are they correct? If you pick one of them, Addie, Barry, or Kathy, you have to be able to justify why it is larger, or why they're correct. Excuse me, not larger, but why are they correct. All right, so that ends this video tutorial.